the algorithm, and I want you to take notes. I want you to take notes as algorithm. Whatever you see on the screen. Algorithm of solving, or for solving, algorithm for probably. So algorithm of solving optimization problems. Okay, so from what you saw, what would be your suggestion for the first step? Find the variable. Define the variable. Okay, it's not the first step for sure. Because I'll tell you why. Okay, you are thinking about the variable before you thought about the function? Even? Like you are thinking right away about the variable, but variable which is going to become part of what? A function. So you should think about function first and then about the variable. So in other words, at the first step, you should ask yourself, what am I to optimize, right? What needs to be optimized? What needs to be optimized? And this is the main question, right? If you don't know what needs to be optimized, there is no point of doing anything. What needs to be optimized? And more, tell me in the question which we saw the video about, what needed to be optimized there? What needs to be optimized? More. I don't know why you're reading the book. You're going to read the book at home. What needs to be optimized? Guys, the idea is about what needs to be optimized in the question which you saw in the video. Guys online, do you have ideas? The area. Good start. The area, but be more, because there are different areas considered there. What kind of area? Describe
the area of a triangle.
A combined area of the triangle and square. That's why, so I'll be giving examples referring to that question, okay? So for example, in that question, we had combined area. That's why he gave an A with the subscript C, combined area, right? So what needs to be optimized? The combined area. Now tell me, if it's a combined area, then how to find it, this combined area? Combine means what kind of operation? Add. Add what?
Addition dimensions.
Dimensions? Length, width, add them all. Adding both areas. So the combined area, this is what we said, I heard the word dimensions. Okay, so the combined area is actually a sum, right, of the area of the triangle.
18.
And now we are speaking like general terms only. So area of triangle and area of the square. Okay. So at the first question, you need to figure out what is it to be optimized. And now, when we say optimized, it might mean find the maximum or find the minimum. For example, going back to the question with the compound, do you remember? So someone wants you to design the compound, and he says optimize the cost. Does this mean that we are looking for maximum or minimum? Minimum. Okay. For example, you are a farmer. How about that? And you want to enclose the biggest piece of the land. Okay. Then it will be maximum. So it optimized sometimes means maximum, sometimes minimum. So what about our question? Who was attentive enough? What was minimum? So in our question, it was about minimum. Okay? It said, how should I cut the wire in order to get the minimum combined area? Okay? So that's the first question. So if I now know what needs to be optimized, what should I do next, do you think? What is the second step, guys? Again, online, people.
We find the area of the triangle and the square, and then we just substitute them and add them together.
Okay, so if I suggest model the function, will that be good?
Yes.
Right, so let's write it down, model the function. Model the function. So model the function in, again, for example, in our example, what kind of a function? What kind of a function was modeled in this example in the video? The area, the combined area. The area, the function of the area, where, what does the area depend on?
Dimensions.
The what?
Dimensions.
Kind, sort of, to a certain extent. This is the wire. The wire is 100 meters. Who remembers from the video, guys, what was the variable he used? What was it representing, this x? The cut. So this area depends on the length of the cut. So for example, I cut it here. Okay, I cut it here. So this length is x. So depending on where I cut the wire, right? I will make this triangle and that square, and their areas will be different. Okay, so this is the function of area depending on the cut. And here you can add that, identify what you were suggesting at the beginning, right? Identify the variable. Identify the variable.
Yes, that's not right.
Okay, so once you have modeled the function, this is where the video stopped. Okay, right? Because he showed the equation of the function and that's it. So you have modeled the function. The rest, I want you to tell me yourselves. Because if you understand the logic of those questions, you will be able to design the steps. So again, we are looking for the minimum of the function. The function has been modeled. So what is the next step? Find the derivative. And the zeros. Find the derivative and its thank you. Zeros. And why are you not taking notes? That's my question. You know it? Oh, okay. So find the derivative and its zeros. Okay. Other than modeling the function, there is another difficult part in this process. Okay, which is, you will tell me now. Okay, if I know the derivative and zeros, and you know the algorithm from last lesson, what else is missing? What else do we need to think about? Interval. And this is not easy. In the question, there will be some information provided, but you will have to figure out which interval you're working on. So determine the interval. Determine the interval. Why do you need the interval, guys? What are you going from that interval? What is important for you to take? There? End points from the interval. End points. Okay, finally, I think I got 6 steps with the others and with you it's 5 steps. 5 steps, you see, it's a creative. We have optimized the. So what is the final step more? Now look, we have derivative and zeros. We have the interval and the endpoints. Going back to the question, I'm looking for the minimum. What to do? Yeah, but we want to know how. Okay, I'm telling you, I have derivative zeros. I have endpoints. Tell me how to find the minimum. Into what? In the area equation, absolutely. Sub zeros and endpoints. And by zeros, please, I hope that you understand that those are not the zeros of a function, right? Those are the zeros of the derivative function. So sub-zeros and endpoints in the initial function. What is important in the initial function? In this case, it's the equation of area, initial function. So I'll add a comment. For example, in this case, it's the area function. Okay? And that's it. So don't forget, of course, to write down the final statement. Look, to save time, I'll not be looking. You can check also the algorithm. In the brackets here, for example, combined area function, okay, which was in the video. Now, the only thing which I want to show you in the presentation to see the difference between the algorithm which we have just designed and the algorithm from homework. What?
I was going to say, make sure that they see.
Guys, do you see my presentation right now? Optimization and the slide.
Yes.
Okay. So this is the steps which are suggested by the textbook. You can look through it. I'm interested only in this part. So determine. There what? Involved? Yesterday was not about word problem. Yesterday is a process. It's an algorithm of finding extreme values. This algorithm is, as you saw, is becoming a part of the algorithm of solving a word problem. Okay, so my question is this. Determine the domain of the function to be optimized using the information given in the problem. What are they talking about? Like, compare this statement with what we wrote. Interval. Yes. So the domain, another word which you might find, meet in, for example, in the textbook, is that interval is the domain of the function in the real life application, right? Which might be different than if we forget about application, right? For example, time, right? Time will always have to be positive. So that's why I'm going to add what else? Domain. Okay, guys. So that's the algorithm. That's it. Just take it and apply. Easy, right? So I have a question. Do you want to take 5 minutes break now, or after another example? After example? And now, no.
You say 10 minutes after the example.
Okay, example, guys. Ready? Example. So the example of the area question. Area questions are the easiest. We also have volume questions, and later on cost optimization and surface area. Okay. So what are we going to do? Yeah, for the volume, for the optimal volume, you can watch this video later on. I'll speak about it at the end of the lesson. So right now we're going to work with the example 1 on page 141. And if you were in my class in grade 10, I was working with you more on this question in grade 10. So you cannot mess it up. Okay, grade 10, yes, seriously. But just we use different tools. Now we have more advanced tools to approach the question. Like similar, maybe different numbers. Okay, so let's read the question. Lila, can you read the question?
I remember.
A farmer has 800 meters of fencing and wishes to enclose a rectangular field. One side of the field is against the country road that is already fenced. So the farmer needs to fence only the remaining 3 sides of the field. The farmer wants to enclose the maximum possible area and to use all the fencing. How does the farmer determine the dimensions to achieve this goal?
Okay. Do you remember the question?
Yes.
Okay, then you know how to do it. Okay, so we are going to analyze this question against our algorithm. Okay, one step by step. Step number 1. What's the first step, Abdurrahman?
What needs to be optimized?
Okay, so look into the question and tell me what needs to be optimized.
The fence, the area of the fence.
The area of what?
The fence.
Do you hear yourself? Area of the fence? Is this? Does this make sense? The area of
Rectangular field.
the field. And as you said, it's a good comment as well. So when you work with the area, for example, right? Not only that you are clear now that you are optimizing the area, it's good to notice also what shape are you dealing with. In this case, as you said, it's a rectangular field, right? So we are optimizing the area of the rectangular field. Okay, good. So that was the first step of the algorithm, right? So what is the second step more? Second step of the algorithm, which we designed together. Model the function, absolutely. In order to model the function, where do you think? Don't look there. Where will you start? You are modeling the area of rectangle. What should you think about? Length times width, absolutely, right? You should think first, okay, what do I know about the area of the rectangle, right? So in this case, I will keep, write some notes. So first we said we are optimizing area. By the way, when you answer the first question, I'm optimizing the area of, and also answer the question, am I looking for a maximum or minimum? Because you remember it might mean both, right? So area of rectangular field, and in particular, we're looking for the maximum. We're interested in the maximum, right? Now, in the second question, we need to model. So when we need to model, we know that the area of a rectangle is length times width, right? So, and now it means that eventually you will have a function which will be a product of expression of length and the expression of width, right? Now, do not underestimate the sketch. I keep saying this, and in particular the word problems, just sketch it right away, because you want to imagine how it looks. And when you start sketching, you will focus on the question. So, this is how the field looks. Now, tell me more. How many sides of this field do I need to fence? 2? 3. So 2 or 3? Look at the question and tell me again. How many sides of the area of the field do I need to fence? Guys online, how many sides? 4. And explain why. Guys online, how many sides do we need to fence?
3.
3 sides. Explain why not 4 sides.
Because it says one side is already against the country road, so it's fenced.
Is already fenced. So I'm going to, on this diagram, I'm going to remove one of the sides because I'm not going to work with it. Why? Because the job has already been done. It has been fenced because it's the road. It's around the road, right? Okay. So now I have only 3 sides involved. Okay. Now, we keep thinking about this, right? We are modeling the area. So it's worth labeling. Where is the width and where is the length, right? We had this discussion in the first period. Guys, which one would be the length and which one would be the width? So the length is normally the longest one. That's why it's called the length. So this would be L and this would be W. And this would be W as well. Okay? Now, according to the question, which dimension did they decide to use as the variable? Which dimension?
X.
The width or the length? Width. They decided, but you can go for length. It doesn't really matter. You'll get the same thing. So they decided that let X, and you can do this. Let X be the width, right? Okay?
So let X equal to.
So basically in this equation, I'm going back to this equation. In the equation of area, I have already one variable, right? Which is X. But I have to express the length somehow in terms of X, right? So what else do we have in the question? We have 800 meters, absolutely. And if you convert 800 meters of fencing into mathematical language, what kind of concept does it represent? No, I mean for this field. Think about it. Those 800 meters, what do they represent?
The whole, all three sides together.
What is it? There is a name for it. Yes, it's the perimeter, right? So normally the perimeter of a rectangle is, what's the perimeter of rectangle? All sides equal together, or you can say 2w plus 2 lengths, right? Because now more. So tell me more. In this case, if the perimeter here is 800, tell me what will be the expression of the perimeter using W and L. What will be the formula? Guys, he needs to work on his own. If you know, write it down and then tell me.
Okay.
So what is, how can you express the perimeter for this shape given that one side of the rectangle is disregarded? Absolutely, you guessed yourself, right?
I guess it is.
Okay, 2w plus 2 width plus length, right? Okay, now, if what is w in our case? X. So it means that 800. Could you close the window, please? So it means that I can replace w with x. Thank you. Right? And finally, guys, why am I doing all of this? You lost the track, right? What? To what? To express which dimension? Length. So isolate length. Abdurrahman.
So it's going to be length equals 800 minus 12.
Absolutely, minus 2x. And now, finally, I reached what I wanted. I got the expression for the other dimension in terms of x. So I'm going back here, right?
It's going to be x times.
Right? And instead of length, I missed you. I missed you. Marwan.
There is no math plus not this is
minus
last 2 months more.
Minus 2x times x. Guys, do you have questions about this equation?
No.
No? Good? Yes? Good? No zeros, right? Okay, so let's move on. Let's check, like, this is the difficult part, right? I told you, modeling is the difficult part. Once you reach there, you're already good, okay? So let's go back to the question. So this is the area equation, and then this is expanded version of it, right? There is another challenge which I told you about. What is it?
There's another what?
Another challenge.
The intervals.
To find the interval, absolutely. Which is the domain of this function. So what do we have here? We have nothing except for our common sense.
Yes.
What can you say if generally they didn't say, for example, that this field has to be not more than that, not less than that, nothing like this was mentioned. They just said a field with the maximum, right? Maximum area, that's it. So using your common sense, what limitations does any dimension have?
From 0 to...
From 0 to infinity.
Yes.
Why from 0?
Because you can't negative.
You cannot have negative dimension. This is the only thing you have, and you're going to use it. So let's go back to our equation. Do you see that area consists of 2 dimensions?
Yes.
Both of them have to be non-negative, right? So this is the idea which is going to be used in order to find the interval. So dimensions have to be non-negative. Have to be non-negative. Okay, so that means, what does it mean in terms of math? You should like consider two different dimensions and create inequalities for them. So what are the inequalities? Who can make up inequalities? Guys online, about you. I need two inequalities.
It's going to be 800 minus 2x.
And where is the inequality?
Is greater than or equal to 0.
Absolutely.
And then x is
X is
greater than or equal to 0.
Yes. Okay? Guys, is this idea clear? So, generally, in these questions, there will be either limitations given by the question, or if they are not given, then it's a common sense. Okay? So, let's solve this inequality. Nur Ginedi, can you solve this inequality? Guys, you do it yourselves and tell me the solution. This inequality, Nur Ginedi.
Miss, can you repeat the question?
I need you to solve this inequality. It's a linear inequality. We used to solve them in advanced functions. Do you know what? You need to solve for x. Nur, it's the
Oh, that's
same.
it. I'm going to solve for x. Okay, so negative 2x is greater than or equal to 800. Negative 800.
Negative 800, yes. Negative 2x is greater than or equal to negative 800. And then the next
So x is equal to 400. X is greater than or equal to 400.
What did he forget about?
I need to flip the equal.
Absolutely. Why? Why do you need to do that?
Because we switched the signs.
Not because you divided.
No, we switched the signs.
Because you divided by a negative. If you just divided by a positive, you would not have reversed the sign. But because
So
you divided
x is less than or equal to 400.
Okay. So now let's look at this and this and combine them. X has to be greater than or equal to 0, or at the same time, and not or, and at the same time less than or equal to 400, right? So we now end up with a double inequality where x is greater than or equal to 0 and less than or equal to 400. And if I want to write it as an interval, then I'll write it from 0, comma, until 400. So that looks exactly like what it was yesterday in the extreme values algorithm. Okay, so great. We have interval. We have the function.
That's 0.
Before getting the zeros. Derivative. Okay, derivative of the function is 800 minus 4x, okay? That's why they have distributed, right? So that you don't deal with the product. Whenever you can first expand, collect like terms, avoid product rule, you should do this, right? So this is the derivative, then you equate it to 0, then the 0 is 200. Now I want online people, Mina, are you here or you left? I'll say the question you guys all think. So what are the three values of x which you should consider for the last step? So what are the three values of x?
0, 400, and 200.
Absolutely. So we take 0 and 200 as the endpoints and 200, right? So you sub them into the initial equation to get the outputs, right? So the maximum is 80,000 square meters. And of course, don't forget about the final statement with the units. That's it. This is the area, this is the question. Congratulations from grade 10. Okay, so it's only the algorithm is different, but modeling is grade 10. So we're going to take 5 minutes break right now. So 10:50, we're back, okay?
Yeah, it's 10:51.
10:50, we're back.
10:51 or 10:50?
10:61.
10:60. 10:60.